Welcome to this year's session at Scamathon, a practical guide to AI-enhanced Tier 1 monitoring. There are three of us that are going to be joining you today for today's conversation. So first off, let me introduce myself. I am Cameron Fuller. I am a former Cloud and Data Center Management MVP.
I'm Matthew Doust. I'm a principal consultant at Quisitive and Microsoft MVP, specializing in PowerShell and Azure automation.
My name is Gavin Fuller. I am a consultant here at Quisitive for the past 4 years now. I have a background in IT with a major in cybersecurity.
Excellent. Well, we are excited to have this conversation with y'all today. Here's the agenda of what we're going to talk through. So we're going to start with the concept of first off, how we even got here. How are we having a conversation related to AI and operational Tier 1 monitoring, and what does that mean? We're going to go into what the Tier 1 challenges are for SCOM, for Azure Monitor, for the rest of the world here, Scorch, Azure Automation. We're going to talk about where AI-based Tier 1 monitoring actually fits, how it applies in terms of things like automation failures. Again, think Scorch or Azure Automation. And then same thing on monitoring in terms of SCOM or Azure Monitor. And then the commonalities between these, because we're looking at this from two different angles. So first is automation failure Tier 1 resolution, and then monitoring alert Tier 1 resolution. That there's commonalities that exist in those. So with that, let's go into how we got here. So first off, if we look back in history from the Scamathon conversations we've had so far, 2024, I did a session called The Rise of Generative AI and Practical Impacts on Monitoring. And we took a look and set the framework for, what is AI? How could it potentially impact monitoring? 2025, we checked back on this concept and is AI living up to the hype? Where are we seeing it in action? Is it actually providing the changes that we were hoping that we were seeing with the rise of this technology in 2024's conversation? And this year, we're going to follow up on that. So for starters, one of the key concepts I introduced is this AI turkeys and microwave ovens analogy. So let me explain that really quickly. In the 70s, when a microwave oven was released, they told us you're going to do everything with this. You're going to make your Thanksgiving turkey in a microwave oven. Fast forward to reality, what we see is no, you don't use your microwave to create your, or to cook your Thanksgiving turkey. But it is an invaluable tool that exists in pretty much every kitchen, and it has specific roles that are defined for it that we know that it's very useful for. Same thing applies when it comes to AI. We're still finding those areas that it's really good at. And one of the differences, and where my analogy starts to break down, is that your microwave doesn't get an update every 6, 12, or 14 hours. What the heck it is nowadays, it could be down to minutes. So it still applies, but we got to put it in context. So today we're going to discuss one of the areas that AI does have strengths and that it can impact monitoring and automation in two different areas. So with that, let's get into where this all fits together. So first, Tier 1. I know I'm preaching to the choir on this one here because probably a whole lot of people on here are dealing with Tier 1 stuff on a regular basis. It's the nature of many of the things that we do within Operations Manager. We do within, again, plenty of the other solutions that I've mentioned before. When you get an alert, those are high volume, they're repetitive, and they're also time sensitive. So you need to know exactly what you need to do with those situations. That means you need human judgment, tribal knowledge, the KB articles that you put together over time that says when this particular issue occurs, this is what we do. Or this is a development or test server, so we don't care, and that's okay. And then manual investigation as well, to look at this and go, okay, this is something new. We haven't seen this before. What do we do with it? It's a whole lot of work. It's not automated, and it accumulates quietly, and it's a continuous process there. So with that, let's get into, first off, we're going to focus this in on a solution that we call QGuard. So QGuard is our piece of the equation focused around alerts. So again, think SCOM, think Azure Monitor, and the rest of it. So with that, Gavin, I'd like you to start with me here. So at a high level, walk us through how QGuard fits into the monitoring stack, regardless of which one that we're monitoring with.
Right. So In general, QGuard sits between our alerting layer, which of course evaluates alerts and determines conditions that we want to monitor, and our human responders. And so when an alert fires, instead of immediately paging a tier 1 engineer at 2 o'clock in the morning, that webhook comes over to us first. In QGuard, we find where the alert originated from. We pull the original query rule that triggered the alert, check our knowledge base for prior incidents, and start running diagnostic queries against real infrastructure. This allows it to act as a sort of untrusted junior engineer taking a first look at a problem.
Okay, no, that makes a whole lot of sense. So with that, so we just talked about where Q guard fits into things from the monitoring alert perspective. Now let's take a look over at this from the Q Auto perspective. So Q Auto is focused again, and this time we're looking at Scorch, Azure Automation. Anytime you run those automations, there can be failures. So when that happens, where does Q Auto fit into a concept like this, Matt?
So as you mentioned, running thousands of automations across hundreds of systems can generate untold number of error messages. And the most difficult part of dealing with error messages isn't how to handle them, it's how to classify them. As most of error messages aren't static. They're going to contain information like email addresses, GUIDs, timestamps. Those are usually generally pretty easy to find and remove. However, things like usernames, system names, paths, you have APIs that will just throw a whole bunch of garbage into the bottom of it for you, right? So being able to classify those and determine, hey, this does match something that I've seen before, even though some items in there are slightly different. So the Q Auto is going to sanitize those for us. So it'll take the list, do some pattern matching, use history and context to then make a recommendation of, I think it matches this previous error message.
Okay, awesome. And for our Scorch audience here, what's the closest analogy? Is this runbooks with approvals, policy-driven actions, something else?
So probably the closest thing to this would be, the run book where you grab down and make the little red line that says, on error, do this.
Okay.
You're going to have that set up. So, in that situation where you can handle specific error messages that you know about. This is the same flow process, except it's more adaptive and it evolves itself over time without having to make changes to the code.
Okay, no, that makes sense. And what happens if Q Auto can't run or loses dependencies? How does a system like this fail safely? Say you can't communicate with an LLM as an example, or machine intelligence, or whatever you need for this.
Yeah. So every component of it is a microservice, and we're using queues on the back end of it. So if any single component goes down, all the requests are queued and held, waiting for that to come back up, as well as using dead letter queues. So if it just gets completely, boggled and it can't figure out what it wants to do, it's going to throw that off for manual inspection at that point. We're
Okay,
also, deployed out multiple regions with front door and traffic manager, and we have two-way communication. So the things that are sending Q Auto the alerts are also checking back in so that we know that both sides are still talking to each other. So overall, it's designed to not fail. It will, degrade, but maintain state so that it can come right back up.
Okay, so in case of any automation failures, in essence, queuing is obviously a good lesson learned there. We want to make sure that we're keeping a queue up for it, and that if we're going to fail, we fail back to what basically would have been the process flow before we had any form of an AI in addition to it. Would that summarize effectively?
Yep. It's a great summary.
All right. Excellent. Thank you, Matt. So let's go through tier 1 automation for automation failures then. Let's hit that for a second. So would you explain the concept of Q Auto for automation or automation failures? Why do we need something like this?
So, a lot of failures are things like transient errors, network errors, system outages, stuff like that. To be able to code for that on every single automation that you have you would just have a humongous mess of code. So what we did is we put it to the platform level so that we can determine, hey, we know this error message, whether that happens with creating a user in graph or creating a group in graph, you're pretty much going to get a similar thing. Same thing, if AD goes offline, Exchange goes offline, those type of things, being able to restart and recover from those particular errors doesn't require human interaction, right? But at the same time, we don't want to build that into every single function. So we build it out so that it doesn't, it will evolve as it goes along. So as we determine more errors, we can, provide those approvals. Hey, this is the path that you're going to take when you hit this one. And then that will apply across the board.
Okay, love it. And for the platform that we're using as an example, like how many automations are we looking at? Because there's always a statistical failure percentage. And even if you're sitting at 5 nines, there's still going to be a range of failures. So like how many automations are you guys running within the platform that you're doing at this point?
Thousands a day.
Okay. So with thousands a day, the likelihood that you're going to have some failures are going to happen. So in essence, as opposed to hard coding for that design, you're providing a method to be able to handle those alerts in a much more intelligent manner. Is that a good summary?
Yeah, because I mean, if you look at the IT landscape nowadays, you have on-prem, you have clouds, you have your third-party applications, and there can be all sorts of things that can go awry in any of that. A great example is if you have an O365 outage, all of a sudden, all of those automations are just going to fail. And when it comes back up, you don't want to have somebody sit there and click a button on every single one of those and then watch them and then go and close a ticket. You want it to just, hey, let's go try again. We know that's back up now.
Yep. All right. That makes a whole lot of sense. Thank you, Matt. So what for your experiences, what's the single most common tier 1 failure that you had to design around?
As I mentioned, is transient errors, right? Network interruptions, locked files, API throttling, service outages, those type of scenarios.
Okay, so things that you can queue up and re-hit at a later point in time and potentially hit with success.
Those probably make up at least 50%, if not more, of our current errors.
So at a high level, would you walk us through how the queue automation fits into the automation stack? What's the architecture look like, Matt?
So we have our automation platform, which goes through, it runs all the individual steps, just the same as like a run book would run each individual step along that process. If something goes wrong, it's going to stop the process there and then fire off an alert. And then what we're going to do is we're actually going to check against a database that contains a bunch of different regexes and previous error messages to see if we have a match, if that's something that we've seen before. And if it is something we've seen before, it'll come back and say, great, I know what to do with this. I either need to submit an automated remediation and then continue on, or I need to open a ticket to have manual intervention. The problem that we ran into with that is, as I mentioned, thousands of automations run a day. Error codes are not always the same and not always the prettiest thing to read. It became a very manual process to go through and review every single one of those alerts that came in, write a regex for it, test it against other things. And, even outside of that, it was, outside of our current ticketing system. So you had to go to a second screen and look up that information. Needless to say, we did not do a very good job of keeping up with it. So by using Azure OpenAI and a large language model, we can have it actually look and suggest different regex patterns and replacement patterns and things like that that come to us, and then produce back a human readable form of that along with it, and then sends that off for approval. And that goes directly into the ticket. So a new alert fires that we've never seen before. We don't know how to handle it. It's going to come through and it's going to say, hey, let me try to clean this up for you. It's going to, attempt to clean it up, make a best effort. And then it's going to write it directly into the ticket. So it becomes one click for somebody to approve on there. And it can produce multiple candidates at the same time. So they can decide, which one looks the best, which one fits the scenario the best directly in the ticket.
Nice. Okay. And as you were making your way through building this, what was the biggest operational or IT concern that you had when piloting this?
I mean, obviously, the biggest concern would be having something go rogue, right? So it, firing off, which is why we've added that approval layer into it so that we can go back and we can say, hey, yes, this looks good. And that's the first time that it fires, it's going to do that. So that we'll know, as it matures, it'll continue to get smarter.
Excellent. All right, so let's go into what information is critical to make a decision, whether that's going to be for an artificial intelligence or for a person. So, as an example, if a tier one analyst has less than a minute to decide whether I need to resolve, escalate, investigate further, what information do they need to have? What's most critical?
I mean, obviously, the best thing to have would be, the error message. But outside of that as well, is the context behind it. Right? So just because you had an error come back, sometimes the error itself is too generic, which is kind of becomes the opposite of the problem that we were discussing. So we also take into consideration the context behind it. What is the automation? What was it doing at that point? What steps, what systems was it talking to, and that type of thing. So having not just the error, but also the context around what it was doing at that point.
Yeah, that makes a whole lot of sense. So let's pivot the conversation towards proof and cost then. So as an example, as you're making your way through this, what KPIs, key performance indicators, are you using to monitor the effect of this solution?
So we started it out, the first one and the obvious one would be the ticket volume. So we started out, our ticket volume went down, I think originally about 13%, and is now down 50% as it's matured and gotten smarter. Beyond that, we're also looking at, time to resolution. So by being able to have that data directly into the ticket, and forgot to mention that part. So our main KPI is is the ticket volume. Right? We were able to take our volume when we first started this out. We took it down by 13%, and which now has grown to almost 50%. And we're also looking at reducing the manual effort. As I mentioned, with like a major outage, you have a lot of things that will get backed up, and and previously had required somebody to trigger, to rerun, to monitor it, and close out a ticket. By having it handle all of that for you directly without even having to open a ticket is reducing your time spent on each individual ticket, as well as your mean time to resolution. By we're taking it and we're actually writing that historical data and things like that directly into the ticket itself, so that when it comes to the tier one, they have an idea of, hey, we've seen this in the past. This is what worked previously for us. Here's where to start your investigation.
All right. What about what surprised you? I mean, specifically, where did the effort shift instead of disappearing?
So when I initially started this, I just used a straight machine learning solution. The problem with that was it was a black box. I didn't know what decisions it was making. I would send it a error message, and it would send me back what I thought it was. There's really no interaction into that process. So the only way to evolve it was to feed more information into it. But soon discovered that became easy to poison. If you all of a sudden had like a major outage and you had a whole ton of the same error message go in, it would start prioritizing that and things like that. So constantly having to roll back the machine learning and the languages and things like that made it very difficult. So I ended up pivoting to the Azure AI with the large language model. And that gave me the pattern matching regex ability that the machine learning did, but also gave me the human readable part and the ability to see exactly what it's doing and approve it in that process as it went along.
Yeah, I would expect that transparency is a key piece of this. I mean, if you can't box this, you really need to know how decisions being made, right?
Exactly.
Okay. And what about costs? What's a baseline cost to run something like this once it's already been put together? And does it scale, or would it need to scale, and would that impact costs?
Yeah, so right now, the entire solution itself costs about $100 to run and a month. Sorry.
Okay.
Uh, and most of that is actually in the app services plans.
Hmm.
So that's, having deployed to multiple regions and, 24/7 availability on that. The Azure AI portion of it, the Foundry, the large language model that I'm calling, I just looked up the last 7 days and it was 86 cents.
Wow.
And, we're calling it a few hundred times a day. And, right now we're sitting at about a 10% capacity with everything that we have running with, so every alert goes through, but obviously it only calls the large language model when there's a new one, right? So we're sitting at about 10% capacity, at that 100, and, it can scale out because, as mentioned, everything's microservices. So
Yeah.
deploy to a new region, deploy a second service, they'll all pick up and they'll all start working together.
Yeah, I love it. I mean, great combination of machine learning, large language model concepts, and the rest of it with a real good practical impact. Because anytime you run automations, there's always going to be a percentage of failure. So we need to be able to tackle those through machine if possible versus sending them all to human. So great intro. I think with that, we're going to go ahead and um, we're going to talk about the cube guard piece of this equation. So we're going to come over to Gavin on this one. So this is to frame the conversation up again. This is focused on alerts. So think SCOM, think Azure Monitor. Whenever a condition is found, it generates an alert. Those require some form of a response. So that's the frame up of what we're looking at today. So for your piece of the equation here for QGuard, Gavin, can you explain the concept of it and what that provides for automation of monitoring alerts?
Sure. So QGuard takes a little bit of a non-traditional approach when it comes to alerts. And so we try to think of our approach not as a computer checking off boxes. We try to think of it as an empowered engineer investigating an alert. And so we give it the tools, the same tools that our engineers would use to investigate alerts when it receives them. And so most tier one alert responses follow a repeatable pattern, right? We receive an alert, an engineer looks at it, they run some queries, check if the condition is still active, look for a blast radius, and make a decision. That workflow is structured enough that an AI agent can do it, but you have forks in the road, right? You have variability, branches. Maybe you find something similar that is also affected or something different that you didn't expect to encounter along the way. So you can't force it to follow on guardrails. You have to sort of embrace the philosophy of this is, in a way, its own individual person working on a task like we would with any of our other engineers. So we don't try to think of it as a chatbot. We try to think of it as an untrusted engineer that we're letting look around and investigate on its own and come to its own decisions. It's never assumed to be correct. We have a human in the loop, and so the humans are always reviewing its decisions. But the end goal and the idea behind it is that we give it a sandbox and we let it think intelligently about the tools that it has available to it and what it believes the correct approach is, as well as empowering it to use those tools to do the sort of investigation that a human would do, even to a higher degree, things like statistical analysis through code execution that we couldn't reasonably expect an onshore engineer to be able to do in the same amount of time.
I like the analogy. I mean, looking at this from the perspective of a virtual tier one person, in essence, makes a whole lot of sense. So that does indeed. So as you're putting this together for alerts, what's the single most common tier one failure that you needed to design around? I mean, what happens the most frequently?
Early closure. The tendency is, and this is not something that's exclusive to large language models, it happens to humans too, is that it's very easy to take a look at an alert and have a glance and say, oh, I've already seen that, or I know what that is, or this maybe you investigate too narrowly. And so A challenge that I found is that it's not necessarily always that we have to check the exact alert and the exact condition as much as it is that we also have to understand the alert holistically, right? What are the implications of this? What other things are related to this? Okay, right? We have an API management gateway that's throwing an alert. Well, what's downstream of that and what's upstream of that? And where do those connect? And so
That makes
we try to encourage it to look at problems not only for the alert that fired, but also consider the ecosystem as a whole, where everything starts, stops, and anything we might find along the way, like a related alert that maybe we are close to alerting on, but we haven't yet.
okay. Excellent. That makes a whole lot of sense. So let's talk architecture then. So as we're putting this together, so what was the biggest operational or IT concern that you had while this was getting piloted?
Yeah, would be giving an AI agent access to read production data in a client's environment, which is understandably a little intimidating. We fortunately benefited greatly from the great work that the Grafana team has done, where we use Azure Managed Grafana already for some of our internal dashboarding. And so what we allow our agent to do is rather than architect a new solution where we deploy app registrations and manage secrets and rotate them, we have Grafana as a single secure surface that the agent touches. That's a read-only surface area, which allows it to connect to our clients and securely read and follow through a single point of entry. So we found that that's very beneficial and very helpful. It keeps everything nice and clean, and we make sure that everything is read-only, not a write operation.
And the type of querying that we're doing in the example with Grafana, that's Kusto behind the scenes, right?
Yes, so that is Kusto query language, and then there's various layers of Kusto query language layered in there. But log analytics is the sort of foundation that a lot of this is built on, as well as there's some Azure Data Explorer that gets tied into there as well.
Excellent. So for our folks here at Scamathon, that means that effectively, since it's in Kusto, any of the different dashboarding solutions that you're maybe already using at this point in time, such as Squared Up, can do similar visualizations to what we're doing within Grafana. Gives a great solution. Squared Up gives a great solution. Some of this is also available in Azure. The key really is to take away from that is that it's Kusto behind the scenes, which really makes the glue that brings this all together. So if you would, Gavin, talk me through what's the architecture look like here?
Yeah, so at its core, we have a function app which handles the orchestration of tool calling, right? The communication between AI Foundry and our model, as well as an extra layer where we track and store the logs around the agents. We track and store decisions that the agent made, its thought process, as well as what tool executions it ran and see where we could improve it and compare it against how a human would do the same task.
Yeah, so I see ticket integration as a key piece of this. PagerDuty shown here as an example. I assume that would work with ServiceNow or whatever other ticketing system you've got, right?
Yes, that's correct. Our architecture isn't specifically built around PagerDuty as an essential core, but rather just something that we happen to use internally for our alerting system.
Right, love it. Thank you. So what about what information is critical? So we've talked about what information is critical from an automation failure perspective. What about for alerts? What data sources turned out to be essential for your solution?
Yeah, so there's a lot of data sources, and the beauty of the sort of nature of LLMs, right, is that they're unstructured, so they're flexible, they're willing to take whatever you'll give them and do their best to work with them. And well, if you stack on too many tools, it will certainly get lost along the way. But what we found is actually that the more tools we give it and the more abilities we give it, it's able still to handle it quite well. So we have internal knowledge bases where we track a lot of customer specific history, as well as specific customer requests, alert histories, right? Trends not only on a given alert at a given resource at a given client, but also across clients. So we could compare an alert, say if we got this alert here, but we don't have any data for this customer, how did we handle it at another customer? And so we found that empowering the model to be able to not just query and look and say, hey, is this still happening? Okay, what's downstream of this, right? But also allowing it to see in the past, what did we do? In our knowledge base, what did we do? In our communications with our in our communications with our customers, what did we say? How did we approach it historically? And then going back through our ticketing system and seeing, okay, has this been recently escalated? What the humans have to say about this, and just giving it the ability to view the stack from the top to the bottom and let it piece together the rest from there.
Okay, and since this is LLM based, do they fail without those sources, or do they provide invalid recommendations? What do you see if it can't get a source it needs?
So as far as sources go, we haven't actually experienced that many failures. There will be bound to be some rate limiting related failures that we're anticipating. But what we really find is that the LLMs pivot great, right? So if it can't read an email, or maybe it can't read our ticketing system, well, great. Let's go to our knowledge base. And even within our knowledge base, we track similar data to what we have in our ticketing system. And so it picks that up and it pieces that together. And we found that it almost makes itself redundant in the sense that it's able to pick up a broken piece and go, oh, this looks broken. Well, how can I get from here to there with what I have?
All right, very cool. All right, so let's go into proof and cost then. So what's the baseline cost to run QGuard, and does it have increased costs with scaling? What causes scaling? Things like that.
Yeah, so baseline costs are very minimal, right? You're looking at a function app, and if you want to get fancy, like we have, storing some of that data and a web app related to that. But in general, right, you have a function app and you have an Azure AI Foundry resource, and so it scales pretty linearly with the inputs. So if we have 0 alerts in a day, our cost is 0. But then, of course, as we add more alerts, that gets more expensive. We found in initial testing that an average alert is less than $1 to investigate, but that does fluctuate based on the complexity of the alert, as well as we're constantly experimenting with new cutting edge models to compare performance and outputs and see if they could offer us say, better performance at the same cost, or comparable performance at a lower cost.
All right. And if you only had like 30 days to provide value or prove value in this, what key performance indicators or KPIs would you point to?
Yeah, so the key performance indicators that we're really interested in are our time to resolution in comparison to a human. So in our initial testing, we found that the LLM averages about a 3-minute time to investigation, significantly outperforming top performing humans. We also want to compare what percentage is it actually able to resolve on its own, because part of empowering it is not just forcing it to make a decision, yes or no. We also want to allow it to tell us when it knows it doesn't know, right? So we consider that in our metrics. We also want to weigh its performance, and so we do that through our database. And so one of our KPIs for that is was the escalation warranted, right? When we resolved the escalation, we escalated it to the customer. Did we do so well? Did we follow our format properly? And did the escalation communicate the data that not only that it found, but that the customer needed to fix the problem?
Very cool. Thank you. All right. So with that, there's also some commonality between these two types of solutions, between the QGuard and the QAuto that we've talked about so far. So we're going to talk about trust, handoff, and maturity next. So with that, so to both of you, we'll start with Matt and then go to Gavin for this one. So what currently must remain as human judgment and why?
So right now, the first pass on the sanitization is human, just to ensure that it's going to match properly and that it's going to handle what it does, and then assigning a automated resolution to that. So we say, this is the steps that you need to take to automatically resolve that. At this point, that is still human, with the end goal of evolving it to learn based upon that information and start suggesting those as well.
Good. How about you, Gavin?
So a few things come to mind. Escalation decisions on anything high severity or ambiguous is always very tricky. The system gathers evidence and it makes a recommendation, but for security concerns, outages with no clear fix, or anything that needs cross-team coordination, a human is always the one making the final call. When in doubt, we escalate. That's the design, and we allow it to, in its own way, it rates its own confidence in its decisions. So we use metrics like that to help us gauge when things are going well and when things really need someone to look at them. So.
All right, good play. We want to hedge our bets where we need to, but let it do what it can do. So for each of your solutions, how do you build trust over time? We'll start again with Matt. So Matt, how do you build trust over time with your solution?
Basically by monitoring it and ensuring that it's doing what you expect it to do, and then having periodic touch bases on it where we go back and kind of run through the audits. Every step along the process is fully documented, and so we can pull that data back up and retrace the steps, every single step of every single automation.
Good. And you, Gavin?
Yeah, so similar to what Matt said, we log everything, right? Prompts, responses, queries, results, and the reasoning that led to that decision. Our reviewers can replay any investigation turn by turn and grade it, and scores are tracked over time by model. We also are building in blind A/B testing, which will allow us to compare performance not only against other models, but also against real humans. So the what we are building this around is the assumption that it is never correct until proven otherwise. So over time, the goal is that we will slowly be able to measurably prove that it performs at or above the level of a human. And as we find bugs and quirks and things to work around, we adjust our prompts, we change the tooling, and we keep building it up and going back and checking our work and seeing how it performs, and continue to iterate and evolve until we get to the point where we find it performs better on benchmarks than humans.
Okay, so then in your case, Gavin, who owns failure tuning, model drift, changes in machine learning capabilities, things like that? Who owns that?
Yeah, so in terms of who owns it, at the end of the day, our monitoring team is responsible for the decisions that it makes. And so that's why having a human in the loop is so important. In terms of actual model drift, we do measure performance over time, right? So we can compare current performance against past performance on similar tickets. And we also don't necessarily have to worry about changes in machine learning capabilities because the model weights themselves are static, right? They don't change, at least not in the current architectures that are out there. And so given that, if there were a drift, we would certainly be able to measure it. But Azure itself is serving the same matrices and and linear algebra at the end of the day, right? So the weights themselves don't change, but we can build up that confidence by measuring that, as well as with our future A/B testing, where we will be able to compare performance in the past to the current.
Awesome. How about you, Matt? Same question. Who owns failures, tuning, model drift, changes in machine learning capabilities?
Yeah, I mean, that's pretty much along the same lines of what Kevin was mentioning. The every suggestion that it makes gets logged into a database, which can then be queried and looked against and determine, hey, does this need improvement? Does this need to be changed? Why did it do this? Oh, because it matched against that. And we can go back and we can tune those over time. And the tool goes back every 4 hours and looks at what it's been doing to make itself smarter on the other ones. So it goes back and revisits these items and says, "Hey, I think we can do this one better. We've seen some additional ones coming in that we think we can adapt these together into one. We combine them in together. So and then adding in the different contexts and things like that. So our team can go through and say, "Hey, you know what? This isn't relevant anymore. Get rid of this," and that will wipe it from the system. No more, poison data or anything like that. Just continually clean up and continue to improve.
I dig it. All right, so visualization. I know we've talked about this briefly. We mentioned Grafana and Kusto and things of this nature. We'll start with you, Matt. So, Matt, how do you know what the solution's doing and why?
So everything that we do goes into log analytics. So whether that is through Azure Diagnostics that feed directly in there, or if it's something that we've custom written to push that data directly into the log analytics, through the API, so that we can combine all that together and see exactly how it ran through the process and things like that. And then tools like Grafana or Squared Up or other dashboarding tools, we can actually bring in additional information. So we can connect to Azure Resource Graph, or we could connect to application insights and get a full, we could see line by line exactly how the code is executing.
Nice. How about you, Gavin?
Yeah, so observability was a design requirement from the start, right? You can't build an AI application and expect that every single time it's going to go perfectly and just assume and treat it like a black box. So every investigation that we run has a persistent correlation ID that goes through our structured logs. And so the complete conversation is persisted to our database, as previously mentioned, turn by turn, with the responses, the chain of thought, tool calls, arguments, tool results, validation, and rejections. So our review web app lets human reviewers walk through any investigation and grade it across 5 dimensions. Nothing gets summarized or thrown away, and multiple reviewers can grade the same case independently, and we track those scores over time. So we have blind A/B comparisons built in, so we can test 2 configurations on the same incident without reviewer bias.
Very nice. Okay. So let's move over to risks and reality as our last big discussion item before we wrap up today. So we'll start with Matt again. So Matt, what's the biggest risk teams underestimate when introducing AI or machine learning at tier 1?
So I guess the biggest risk would be giving it too much power, too much autonomy. Right? You want to use a phased approach, and I approach this the same way that I approached any automation project that I do. If you're going to come in and you're going to try to automate 100% of the process, you're going to fail 100% of the time. Let's take that 80% high impact, easily repeatable, known processes, get those in there, get those working, and then we start building out for our edge cases. And then, over time, slowly increase that until you're at that 100%.
Love it. And how about you, Gavin? Let's switch to, what dependency surprised you the most? Was there anything that you were surprised that you needed or the LLM needed to make educated decisions?
Yeah, so actually, the surprise dependency for me was the within the grand scheme of things, although I'm quite familiar with the Gusto query languages, both of you are, much more so even. In general, in the grand scheme of query languages or even structured languages, right? KQL is pretty niche. It's pretty domain specific. It's not as popular as something like SQL. So KQL is underrepresented in training data. And so one of the interesting dependencies that we found was that we actually have to very strictly validate the KQL going in, because incorrectly structured KQL is produced pretty consistently. So we've built in sophisticated layers that actually do help nudge it and find linting and parsing errors and things like that. But the second biggest, I would say, was data quality, and that's our data quality is very good. But the problem is that there's so much variation, not only between alerts and between resources, but also between customers, teams, and even individuals. And so the beauty of the LLMs is their ability to pick up these differences and these changes and work with them. But we still have to help nudge it in the right direction. And we found that that was surprisingly caused more friction than anticipated.
Very nice. All right, last question for each of the three of us today. So to Matt first, what would you recommend for everyone on today's conference regarding AI, machine learning, and tier one?
Start playing with it. Yeah, it's it's a very low entry to get in and start building it. It can look rather intimidating, but believe it or not, I built 80% of this solution with AI helping me build this solution. So even the prompts, you can get an AI to help you build your prompts and clean up your prompts and ensure that you're going to get good, clean, consistent data. So getting in there, getting the data, as Gavin was mentioning, getting good data is very key. But just getting out there, even if that's just going to Chat GPT and throwing an error message in there and asking it for recommendations.
So Gavin, what would you recommend for everybody at today's conference regarding AI, machine learning, and tier one?
I would say get a Codex subscription, get a Claude Code subscription, get a GitHub Copilot subscription, and don't be intimidated by them. Don't be scared. Like Matt said, they really do hold your hand the whole way. Don't overtrust yourself. They will lie to you, and they will do silly things that they shouldn't do. So I'm not suggesting that you push directly to production from that. But what I am saying is if you're coming from a low code or a no code background and you go, well, coding's too complicated, it's too scary. These have bridged that gap significantly. And I firmly believe that anyone empowered with these tools and the right time can come up with countless ideas of ways to build something they like, build something that can help out their business, or have fun with them. And just sit down and just spend an afternoon or an evening trying it out and seeing what you can build, because you'll really be surprised with the latest models, the GPT 5.4, which recently released, Claude Opus 4.6, and many others that are recently coming out. The barrier to entry to coding, as well as in general, anything to do with AI, has never been lower. There's never a better time to learn. And as these tools continue to evolve, you will benefit substantially from learning them.
Yeah, love it on both cases. I echo both of your statements on those in terms of what people should be looking at. And I just say that holistically, maybe tier one is something that you should look at within your environment. Maybe it's something that, AI would be helpful for in some capacity. Look at it there. Or if you've got other pain points, I'd say the big takeaway at this point is the AI capabilities out there have extended significantly over the last year. The types of things that we can do now are far, far greater than what we used to be able to do. So if tier one isn't your biggest problem, go grab your biggest problem. And what I recommend in terms of AI is AI first. Even if it's not your default, take it to AI and get some thoughts on it first. And then the second thing I'll always say hand in hand with that is fail fast. You can spend a whole lot of time trying to get AI to do something it just can't do, and that's okay. Fail fast, learn what it can do, what it can't do currently, and that changes daily. But use that as your mantra going forward. So start to embrace it, start to use it. It's going to be key for all of our careers as we make our way going forward. So with that, I think we're going to go ahead and wrap up. I did want to give some contact information for the three of us here. If you want to follow up, if you've got any questions you want to ask or anything that we can help you with, we have been glad to do this conversation today. Glad to be part of Scamathon, and appreciate everyone who has made it to today's session. I hope you found it useful, and I think with that, we will go ahead and call it a day. Thank you all very much, and I hope you have had an incredible Scamathon.